what we're going to look at here. We're going to really change gears from what we've been doing. We're going to learn how to graph exponential, and then later on in class, we're going to learn how to graph logarithmic equations. Okay. Now, put your worksheet to the side just a little bit. Let's talk about, well, what do we mean by an exponential equation, or in this case, we're going to look at what we call an exponential function. Okay. The big idea is this: the exponent is going to be unknown. Okay. So the x or whatever variable that we're talking about is going to be in the exponent. Okay. Now let's look how we graph an exponential equation. Right. So we've got y equals. Now probably what you're going to have is this might say, instead of y, it could be f of x or t of x. Okay. I'm just going to say y equals 2 to the x power. Okay. So notice what makes this an exponential equation here is that the x. What's different here? The x is the unknown and it's where? It's not like a normal number. It's an exponent. That's the key. Okay. Now, here's what we do. Now we kind of look at basically three things, and it's not real difficult, right? First thing, ask yourself, all right, what makes the exponent equal 0 and equal to 1? And what we're going to do with those values is put them into a t-table. Okay? Now in this one, it's pretty simple. What would make this exponent right here, this unknown exponent, what would it make it 0 and what would make it 1? What would make it 0? 0. Yeah. And what would make it 1? 1. Pretty simple. Okay. Now, let's talk about, well, why do we choose these values? We choose these two values, 0 and 1, because they give me really, really nice numbers. What's anything raised to the 0 power? 1. And then what's anything raised to the first power? Yeah, itself. Okay? So that gives me really, really nice numbers to work with. Now, we'll do that in just a second. Now, the other thing that I'm going to look at, so there's like two things right there. The other thing is going to be the horizontal asymptote. Now, the horizontal asymptote is basically going to come from the vertical shift into the graph. Even though we're not doing these by transformations, we're doing these kind of by what I call my method. Okay? We look at it like from the vertical shift. All right? So, real quick, let's just go to an easy graph that we should know, like x squared is a parabola, right? Now, what if I added 3 to it? What would it do to the parabola? We shift it up through. Okay? So this is where the vertical shift is going to come from, and that's going to give me a horizontal asymptote. Now, let's go through this, and then we're going to sketch the graph, and then we're going to find the domain and range from the graph. Okay? So now, let's start off, and what we're going to do is we're going to make a t-table, and we're going to pick values of x to do what we said over here. It makes the exponent 1, it makes the exponent 0. Okay, so in this case, since the exponent was just plain old x, what made the exponent 0 and 1 would just be 0 and 1, right? Now, how are we going to get the y coordinates, you think? Yeah, just plug it in. Okay? So let's take 0 and plug it in right there for the x. So 2 to the 0 power, anything to the 0 power is going to be 1. Anything raised to the 0 power is 1. And now, let's plug the 1 in. So 2 to the first power, yeah, just 2. Now, the horizontal asymptote, That's the third thing. So all I need is I need 2 points in a horizontal asymptote to do the graph, and that's going to be it. Now, horizontal asymptote comes from the vertical shift. Now notice, you just had 2 to the x. So you didn't have like +2 or like +3 or -4 or anything like that. Okay? So what do you think the vertical shift is on this one? 0. Okay? So the horizontal asymptote would be y equals 0. Okay, so you remember what we've used that abbreviation before. HA is for horizontal asymptote. So the horizontal asymptote comes from the vertical shift. Now, in my next example, we're going to throw in a little extra something. Okay, so if I had like this, what would be my horizontal asymptote then? Y equals -5. Okay. Now let's graph it. Okay, and we're not going to get real fancy with the graphs. We're just going to sketch them all. Okay, so I'm going to plot my 2 points. We got 0, 1, and then 1, 2. Okay, so let me do. Let's see, 0, 1, right there. And then 1, 2, right there. Now, let's put in our horizontal asymptote. So let's talk about what do we mean by the horizontal asymptote? Well, this is, by the way, this is a curve. So it's going to be a curve through these 2 points. But the horizontal asymptote is y equals 0. Now that's horizontal. It's a horizontal line, right? It's going to be going through the origin 0 right there. So how do we do those on the graph? Vertical and horizontal and slanted asymptotes. So kind of note on the graph that they're not actually part of the graph. Yeah, they're dotted lines. Okay, so we have a dotted line with a horizontal asymptote y equals 0. Okay. Now let's draw the graph. Now the graph is a curve. Okay, so keep that in mind. So it's going to be a curve through those 2 points, and then what curves do the asymptote? They chase them. So it's going to get closer and closer, but it's not going to touch. Okay. There we go. Through there. So there's the graph. That's how you graph an exponential equation. You look at what makes the exponent 0 and 1, and then you figure out the horizontal asymptote, and that's all you need. Now, let's find the domain and range. So remember what the domain is, all the possible x values, and then the range is all the possible y values. Remember how we scan the graph? How do we scan the graph to the domain? Yeah, left to right. And then the range, we go from top to bottom. Okay? So if we scan from the left to the right, what it would go to negative infinity, right? No, but here it's going to keep going to the right even though I'm actually stopping. It's going up more so than it is going to the right, but it's still going to the right forever. So what is that going to mean about my domain? Yeah, all reals. Okay. Or you could say, like some of y'all were saying, what, negative infinity to positive infinity, which is the same thing. Okay. Now, the domain for these is always going to be all reals. Okay. Now, the range is what's going to be limited. So notice when I do my range, from when I go to the bottom to the top, you don't have any values down here, do we? Okay. The values for the range just start really at 0 and go up. Now the problem is that it doesn't actually touch 0. So what do we do about that when we name this range over there? We're going to say 0, but how can we say, well, it's not really going to touch 0 then? Parenthesis, right. So 0 to, now, does it go on forever? Does it go up forever there? Yeah. So it'd be 0 to positive infinity. Now, let me get a couple of predictions from you. Okay. What's going to happen, you think, if we would throw like a negative in front of the 2, like that? What do you think would happen to the graph? How would you get it? Right. Would flip
down
downwards.
over the x-axis.
Right. You flip over the x-axis. if I made the exponent negative, like if it was 2 to the negative x, then it would flip across the y-axis. Okay, and we'll actually see one of those two happen. All right, let's look. Let me do another example with you, and then y'all can kind of give me some input if y'all think we need to do a third. Okay, this one, let's put it in a function notation. So we've got f of x equals 2 to the x plus 1 minus 1. Okay, now let's go through. All right, what are the three things that I need to know to graph it? I need to know and 1. All right, what makes the exponent 0? What makes the exponent 1? And the horizontal asymptote. All right, those three things. Okay, now let's start off with my t-table. All right, so y'all look at the exponent. Now this time the exponent is not just x, it's x plus 1. Okay, so what would make the exponent 0? Right, if x was negative 1, then that exponent would be 0 up there, right? Y'all follow me?
No.
All right, the question is, what makes the exponent 0? So what value of x right there would turn the exponent into 0? Negative 1, because negative 1 plus 1 would give me 0. And so then I would have 2 to the 0 power minus 1. Now, what's 2 to the 0 power going to give me? 1. And then 1 minus 1 would just be 0. Okay. Usually the hardest part for people is the y coordinate. Okay, it's plugging it in. All right. So remember, all right, we're not to the horizontal asymptote yet. We're just getting the two ordered pairs. That's what made the exponent 0. Okay. Now we're going to put in what makes the exponent 1. If x was what value, what would make the exponent be 1? 0. The 0 plus 1. So if x right there was 0, then my exponent would just be a 1. Okay? So if we plug in 0 right there, what's that going to give me for my y expression? What? 2 to the first power minus 1. Now, 2 to the first power is just 2. And then 2 minus 1 is just 1. So y'all kind of understanding why we want the exponent to be 0 and 1?
Can I? Okay, so like on the x values, like it will always cancel down. Like negative 1, 0, 1, 2, 3. Like
No, not always. Okay. You're just going to have to figure out what makes the exponent 0, what makes the exponent 1. Now, if it's something complicated, then you take the exponent, you set it equal to 0, and you set it equal to 1 to figure it out, okay? Now, they're not going to be more complicated than that. Okay, they're actually going to be pretty simple if you could just name that. Now, go back to my question. All right, why do we want these values? Those are really nice, aren't they? Because what's going to be anything right there to the 0 power? 1. And then what's going to be anything to the first power? Itself. Okay, so those make me really nice ordered pairs to work with. All right, so we got what makes the exponent 0, what makes the exponent 1. Now the other thing is the horizontal asymptote, which comes from the vertical shift. Now we actually have one this time, so it's not going to be y equals 0. So what's my vertical shift here? Yeah, the negative 1. So the horizontal asymptote would be y equals negative 1. Okay. Now, let's graph this up. Alright, so let's graph like negative 1, 0, and then 0, 1. So negative 1, 0, there's 0, 1. Okay. Now, let's graph our horizontal asymptote. Y equal negative 1, so there's where y is negative 1. Now, how do we do an asymptote again and make it different? The dotted line. Okay. Okay. Now, all we got to do is, this is a curve. All exponential equations are curves. It's going to be a curve through those 2 points, and it's just going to chase the asymptote, right? Get closer and closer and closer, but not touching. Okay. So let's something like that. Okay, now let's do domain and range. Alright, so what do y'all think about domain? All reals.
All those numbers.
Okay. And then the range, so we do the range where we're going to go from the bottom to the top. Now we've got issues with the range here. Right, there's nothing down here, is there? So it's going to be what? Anything from here on up. I don't want to do it like that. Stop it. Alright, like that, right? Okay, so what is this value right here? -1. Now we don't actually include it. Okay. So how do we account for the fact that we're not touching -1? Yeah, parentheses. So -1 to infinity. Now, alright, y'all talk to me. It's not. All right, y'all want to do one more example, or are we good?
Do one more.
Do one more? Okay. All right. Here, you can have my first one. Okay. Especially like right here, this part. All right, let's do this. Okay. Now, notice what's a little bit different on this one is the exponent is negative this time. Now, all that's going to happen to the graph is when the exponent is negative, what do you think it's going to make the graph look like? The y. Okay? So, instead of like from the left to the right, instead of going upwards, it's going to go downwards towards the asymptote from the left to the right. Okay? Now, so let's see, let's do our t-table. So what do we put in the t-table? Values of x that make the exponent 0 and 1. So what makes the exponent 0? 0. So now let's plug in 0. So that will give me 3 to the 0 power plus 2. Alright, so guys, what's 3 to the 0 power? 1, and then 1 and 2 would be 3. Good. Now, the other one is, what makes the exponent 1? Right? If x is 1, then I would have 3 to the -1 power. We want positive 1, don't we? So it needs to be -1. Now, you see how it would work, because what the negative and the negative would just turn to a positive 1. Okay? So now, this will give me 3 to the first power plus 2. So 3 to the first power is just 3, and then 3 and 2 would be 5. Okay. Alright, on, you okay? This makes sense a little bit? So just these values right here, what we're doing is we're choosing values that make the exponent 0 and make the exponent 1. Because anything raised to the 0 power is always going to be 1, and anything raised to the first power is itself. Okay? And so those gives me really, really nice points that way. Now, the other one is going to be our horizontal asymptote. Now, the horizontal asymptote is going to come from the vertical shift. What's the vertical shift part here? Yeah, the plus 2. Okay, just like in what? That equation right there, x squared plus 3 makes the parabola shift up 3. Okay, that's going to make the graph shift up 2. So the horizontal asymptote will be y equals 2. Okay, now let's graph it. Oh, this sucker, I'm sorry. Okay.
Oh my God.
Right. Thank you. That's so important that we remember words like that. All right, here we go. All right, 0, 3. It's up there, right? And then -1, 5. Okay, let's put them on there. We got 0, 3, and -1, 5. Now, y'all see how that's going to make the curve go downward from the left to the right instead of upwards from left to right? That's what the negative in front of the exponent is. Now, let's graph the asymptote here, y equal 2. the y is 2, so that's our horizontal asymptote. So a dotted horizontal line. And then all we got to do now is just draw our curve through those 2 points and chase the asymptote. Look something like that. Now, let's do this. Y'all flip over on...
Oh, Mr. What was the right summary?
Oh, I'm sorry. Yeah, I forgot about that part. Yeah, domain and range. Let's put that on. All right, so what would the domain be? All real.
Is it always something off?
Yeah. For an exponential, it's always going to be all, because it's going to go forever from the left to the right. Now, from the bottom to the top, though, it's not, what the graph really doesn't start until positive 2, and it doesn't touch 2, so that means we use a parenthesis. So it will be 2. Now, after 2, it goes up forever to be 2 to infinity.
Even though
Okay. What we're doing, all we're doing is we're getting the graph. The graph is the answer. Okay. And then, so the graph is like part A, and then the domain and range is like part B. Not a big part B. But the way I get the domain and range is from the graph, right? So I get the graph, I can get the domain and range. Now later, I'm going to show you how you get domain without the graph. Now, let's do this. You'll do this with me here. Pull it up. Switch to my docket. Right. Now, look on the side where it says graphing log functions here. Now, let's do a little bit of stuff first here. And so now we're switching to logarithms. So with logarithms and exponentials really are inverses of each other. So what we've got to do here to get some like review stuff out of the way from Algebra 2 is look at the definition of a logarithm. So I say logarithm, but we write LOG for short. So definition of a logarithm says this, all right? You have a logarithm of b. Now, what do we call b? We write b because it stands for base. Okay. So that's the base. So it's like a subscript number. You know, kind of like an exponent is a superscript number. It's smaller and it's like high. This is a subscript number. It's smaller and even lower. Okay. Now, this value right here, x, okay, and we can just put anything really right there. This is called the logarithm. X is called the log, even though this log stands for logarithm, the logarithm is the x value. Now, is equal to, now we're just going to make a value up, y, and really what y is y is an exponent. Even though it's not written like an exponent is, it represents an exponent. Okay? Now, if we have this, then really what the definition says is this is an exponential form. Okay? So logarithms and exponentials are inverses of each other. So I could write this in an exponential form. Now see if you can remember this from Algebra 2. So something raised to some power is equal to some number, is what it's saying. So what's our something raised into what power? This raised to the y power is equal to x. I remember that from Algebra 2? Okay, so then b raised to the y power equals x. All right. Now, let's do this. We're going to look at some of these problems here from your worksheet on the graphic log functions. Now, what we're getting to, we graph exponentials. What I'm trying to get you to eventually by the end of the class is to graph a log function. Okay, that's something that you didn't do in Algebra 2. Now, let's look at these even problems right here. So it says write each equation in its equivalent exponential form. So all you're doing there is just using the definition of a logarithm. Right? So I wrote the first one for number 2. What? 2 raised to the 6th power is equal to 64. Okay? Now for these even ones, let's go ahead and let's say and let's write what would be the exponential form there. 9 to the 2nd power equals x. Okay? And we're not trying to figure out what x is. Now we could figure out what it was there, couldn't we? We're not trying to do that. Okay? All right. Number 6 would say what? B to the 3rd power equals 27. Notice these are a little bit backwards from the definition that I wrote here. Okay? It's really no big deal. This one would say what? 5 to the y power equals 125. Okay? Now, let me get me a new sheet here. We can talk about next. Now, the next step we're going to skip over. The next step goes through basically the same thing that just goes backwards. So this is an exponential form. It's asking to write log form. Now, this really doesn't have much application. So we're going to skip it, and I'm trying to skip over as much as I can because we've got to squeeze in our 6 weeks test before we leave. Because I'm sure y'all don't want to come back the first day and take the 6 weeks test. Christmas, right? Okay. That's why I'm kind of rushing here a little bit. I'm rushing today, and we'll slow down a little bit more. Now, and we're just going to look at the next step. We're going to evaluate a logarithm. So when you evaluate a logarithm, what you're trying to do is you're just trying to figure out what is this equal to. And so the way that I figure this out is I just think of it in an exponential form. Okay, just like what we said with 2 here, with what? 2 to the 6th power equals 64. Okay, so what I'm going to say here, since I don't know that value, I'm going to say what? 4 raised to what power would be 16? 2. Does that make sense? All right, let me look. Because what? 4 to the 2nd power would be equal to 16.
Oh.
Does that make sense now? Okay. Now, let's go, let me do number 23 with you. Okay, in a minute I'm going to let y'all try the even ones that I'm leaving behind. Okay. Now, this one, even though it says without using a calculator, I'm going to let you use a calculator here. But let's just go through not what the answer is, but what's the question that I'd ask myself. 2 to the what power is 64. Okay. So let's see. 2 to the 3rd power is what? 8. It's not 3. Okay. So just keep going until you figure it out. 2 to the 4th power is 16. Okay. 2 to the, you'll get the pattern. 2 to the 5th power would be 32. So 2 to the 6th power is 64. So the answer just would be 6. Okay. Now, before we get to 25, I'm going to go to the side here, and you may want to write down a couple of rules. All right. Exponents. All right. If I have x to the negative 1 power, what's an exponent rule here that I can use to make that positive? I call it the elevator rule when I taught you guys now. So what can I do to make this exponent a positive exponent?
Make it
Right. All right, remember that now? X to the negative 1 is the same thing as 1 over x. All right, here's another one. What about x, and what if my exponent is a fraction? That's really confusing. X to the 1/2 power. What is that really the same as? It's a radical. Square root of x. You remember what happens is the denominator is the index, and right in a square root the index will be understood 2, and then the numerator is the exponent right here, which is an understood 1. Okay, so if I say something to the 1/2 power, it really means the square root of that, doesn't it? Okay, so if I were to ask you, okay, what's 25 to the 1/2 power then? It's just 5, because 25 to the 1/2 power would mean really the square root of 25. Okay, now we're going to keep these two rules in mind here when we go through these next problems. Okay, now, all right, let's look at number 25. All right, so we've got log base 5 of 1/5. So 5 raised to what power is 1/5? Now let's back up just a second. Let's just look at the 5. 5 raised to what power would be just 5? 5 raised to the first power would be 5, right? Now here's the thing. That's not 5, is it? It's 1 over 5. So how can I make the 1 over thing work? It's not a fraction. It's not a root. It would be -1. Think about that. Wouldn't 5 to the -1 power be the same thing as what, 1 over 5? Now go back to what I was saying. Let's just pretend that that's just 5 right there. So 5 raised to what power would be 5? 5 raised to the first power. Now if it's 1 over 5, that just means it needs to be to the negative first power, or the -1 power. Okay, look at number 27. I think you'll get this one a little bit better. Now, don't look at the 1/8. Okay, just think about the number 8. 2 raised to what power would be 8? 2 to the third was 8. Now it's not 8, it's 1 over 8, so it needs to be 2 to the -3rd power. So my answer there would be -3. All right, y'all following that okay there? All right, now let's go to number 29. This. Go away. Okay. Now, I'm going to ask what 7 raised to what power is equal to the square root of 7? To the 1/2 power. Because what does 1/2 power really mean? Square root. Okay. Now, what if I had cube root of 7? It would be the 1/3 power. So cube root means 1/3 power. Square root means 1/2 power. All right, let's look at number 31. Let's see if you can get this one. Okay. All right, now let's think about it. It's not too bad. 2 raised to what power is 1 over the square root of 2? Now let's just do square root of 2. So if it was just square root of 2, we would say to the 1/2. Now because it's on the bottom, it would be -1/2. Does that make sense? All right, listen to me. The square root of 2 means it would be, what, 2 to the 1/2 power, right? Now, since it's 1 over the square root of 2, since the square root of 2 is in the denominator, then it needs to be to the -1/2 power to put it down in the denominator. Okay? Now, let's look at 33. All right. This says, we'd ask ourselves here, all right, 64 raised to what power would give me 8? Well, that's kind of confusing, but think about, you could take the square root of 64 and give you 8, right? So instead of taking the square root, we could think of it to the 1/2 power. Does that make sense? Okay. So the answer here would be 1/2. 64 to the 1/2 power would be equal to 8. Because what does the 1/2 power really mean? Square root. Okay? Alright, let's look at number 35. This one's kind of easy. 5 raised to what power is equal to 5? 5 to the first power. And that's really no big deal there. Okay? Alright, let's look at 37. You got to think of this one. 4 raised to what power is equal to 1? 0, right? Anything raised to the 0 power is 1. So right here, you know, you had 4 right there, right? But that could have been any number, couldn't it? And that would have worked. All right. Let's look at 39, and then I'm gonna let y'all do the even. We're not gonna do these two now. Just scratch it. All right, number 39. This one's pretty simple. 5 raised to what power would be 5 to the 7? Five raised to what power? 5. Steph? All right. Watch. What? 5 to the 7th power is 5 to the 7th power. Okay. All right. Now y'all do this. Okay. Y'all do the even ones that are left over there. Okay. And then we'll try to. I'm gonna give you like 2 minutes to run through them real quick. Okay.